Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Here is problem 119 on series parallel pipes. Calculate the discharge in pipes 2, 3, 4, and 5 and the total head loss in the pipe system shown if the discharge through pipe 1 is 360 liters per second rightward. Also determine the pressure at point C and D if the pressure at B is 300 kilopascals. So here is the given figure, and this figure here, we have pipes that are on the same horizontal plane. That's the assumption. This is the plan or the top view. And these are the given information and the properties of the pipes. So for the solution, we have Q1 equals 360 liters per second, and it is also equal to Q sub 6 by principle. Therefore, we can compute HF1 and HF6. The total head loss in the system is HF1 plus HF2 plus HF6. We cannot solve HF2 yet, but we can compute HF1 and HF6. Then the formula for head loss by Darcy-Weisbach formula, because the friction factors are given in its pipe, is 0.0826 FLQ square over diameter to the fifth. So HF1 is 0.0826 times 0.025 times 1200 times 0.36 squared divided by zero point 0.5 to the fifth. The discharge is 0.36. So HF1 is equal to 10.277 meters. HF6 is 0.0826 times 0.025 times length 1500 times 0.36 squared divided by diameter 0.6 to the fifth. So HF6 is equal to 5.1625 meters. Then from here, we can have HF3 equals HF4. Pipes 3 and 4 are parallel. Then also Q1 is equal to Q2 plus Q3 plus Q4. That is Q2 plus Q3 plus Q4 equals 0.36. And we can relate the discharges between 3 and 4 because they have the same head loss. So HF3 equals HF4 because 0.0826 is common. I will not write 0.0826 anymore. We'll proceed to friction factor. So 0.025 times 1500 Q3 square divided by diameter 0.3 to the fifth equals 0.023 times 1800 Q4 square over 0.35 for pipe 4 raised to 5. From there, we can express Q4 in terms of Q3, and Q sub 4 is equal to 1.39921 of Q3. Then likewise, Q3 plus Q4 equals Q5. And since Q4 is expressed in terms of Q3, so Q3 plus 1.39921 of Q3 equals Q5. From there, we can express Q3 in terms of Q5. So Q sub 3 is equal to 0.416804 of Q5. Then also, HF2 equals HF3 plus HF5. So also Q4 is equal to 1.39921 of Q3, and Q3 is 0.416804 of Q5. So Q sub 4 is equal to 0.5832 of Q5. So likewise, HF2 is equal to HF3 plus HF5, so that we can relate the discharges between 2 and 5. So again, 0.0826 is common to these head losses here. So I will no longer write 0.0826 anyway. 0.0826 will be cancelled. So HF2 0.022 times 2500 Q sub 2 square over 0.4 raised to 5 equals HF3 0.025 1500 Q3 square, wherein Q3 is 0.416804 of Q5. So quantity square over diameter 0.3 to the 5 plus HF5, which is 0.018 times 1000 Q sub 5 square over 0.45 raised to 5. Simplifying, this is 5371.09 Q2 square, and the right side combined is 3656.41 Q5 square. From there, we can express Q5 in terms of Q2. So Q sub 5 is equal to 1.212 of Q sub 2. Then substitute into equation 1, Q2 is Q5 over 1.212, Q sub 3 is 0.416804 of Q5, which is this. Then Q sub 4 is 0.5832 of Q5. From there, we can compute the discharge in pipe 5, and it is equal to 0.1973 cubic meter per second to 4 significant figures. To 5 significant figures, it is 0.19725. So don't be surprised that I'll compute Q2 here as Q5, which is 0.19725 over 1.212, because this is the value of Q5 to 5 significant figures. So Q2 is 0.1627 cubic meter per second to 4 significant figures for our final answer. Then Q3 is 0.416804 of 0.19725, which is Q5. So Q sub 3 is equal to 0.08221 cubic meter per second. Then Q4, which is this, 0.5832 times 0.19725. So Q sub 4 is equal to 0.1150 cubic meter per second. Then the total head lost. But before that, let's solve for HF2. This value here times 0.0826, which I did not consider before, is HF2. So we multiply this by 0.0826, then this is HF2. So HF2 is 0.0826 times 5371.09 times Q2, which is 0.1627, then quantity square, 0.1627 square, then it is 11.744 meters. HF3, on the other hand, is HF3, which is this, times 0.0826. So HF3 is 0.0826 times 0.025 times 1,500 times Q3 square, and Q3 is 0.08221, quantity square over 0.3 to the 5th. It is 8.6150 meters. So the total head lost is equal to 10.277 plus HF2 11.744 plus HF6 5.1625. So the total head loss from A to E is equal to 27.18 meters. Then if the pressure at B is 300 kilopascals, remember these junctions or all these pipes lie on the same horizontal plane. That's the assumption. And this is the top view or plan. Then the pressure at C is equal to the pressure at B minus the pressure drop, which is equal to the specific weight of the flowing liquid, which is water, times the head lost in pipe 3. So that is, pressure at C is 300 kilopascals given, minus specific weight of water times head lost in pipe 3. So P sub C is 300 minus 9.81 times 8.615. So the pressure at C is equal to 215.5 kilopascals. Then for the pressure at D, it is equal to the pressure at B. Then since B and D are connected with pipe 2, so pressure at D is 300 minus specific weight of water times the head lost in pipe 2. So 300 minus 9.81 times 11.744, and it is equal to 184.8 kilopascals. So that's it.